Hey everyone, it's Mr. Lang. In this video, I'm going to be teaching you about compound interest. And you're going to see that compound interest is really just a real-world application of the exponential function. So if you got a piece of paper, a pencil, and you'll want a calculator, then you're good to go. So let's get started. Alright, let's start off with the compound growth formula. It's A is equal to P times quantity 1 plus R raised to the t power. And let me explain to you what these are. This is actually just a fancy form of the exponential function, but I'll talk about that in a second. The A is your final value. It's your final value after the t here is however that much time. It could be years, a lot of times it's years, it could be days, could be whatever. So the final value after that much time. Now the P stands for the starting value. And the R stands for the rate as a decimal. And that's important. So I know these are kind of weird letters, they don't really match up with, you'd think it'd be an F or whatever, but this is kind of the classic formula for compound growth. Now to find the rate, all you do is you take your percentage and divide by 100, and we'll go over that. But remember what the exponential function general form is. It's y equals a times b to the x. This is almost the same exact thing. The start value here, this is your start value here, or your y-intercept. This was your growth rate, the little b there. When you put this together and actually add them, that is your growth rate. And the x and the time match up. So this is compound growth. Compound decay is almost the same thing. The compound decay formula is the same exact thing except for it's a minus there. That minus tells you it's decay. So if it's growth, you use a plus the R. If it's decay, you use the minus R. So what we're going to do is do two problems together. We're going to do one growth and one decay, and then I think that'll be good enough for you to get started on the sea of questions. Alright, so example 1. You put $100 into a bank account that earns 7% interest compounded annually. Compounded annually, that compound tells you that it's exponential. How much do you have after 40 years? So first of all, 7% on a bank account, you will never get that in the real world. You will get like 0.5%, but regardless, this is just an example. So this is exponential growth because we're earning money. So we're going to use the formula here. A equals P1 plus R to the T. My final value is what we're trying to get. My initial value is 100. I'm going to have 1 plus, and my R, the way we figure that out is we take the 7% and we divide it by 100. Alright, that's how you make that percent a decimal. And when you do that with your calculator, you should get 0.07. So that is our R value. And for the moment, I'm just going to leave it as T, to leave it general. So to simplify this, this would be A is equal to 100 times 1.07 when I add 1 and 0.07 to the T. Now this is my general formula. I could plug in any number of years for that T and find out how much money I would have. But in this specific case, we want to find 40. So I'm going to plug in the 40 for that. And I'm going to get my answer here. So take a second, you plug in the 100 times 1.07 to the 40th. I'll do the same thing. Let's see what we get. Alright, I got mine. I got 1497.44 5784. And you're like, well, do you want to leave your answer with all those decimals? No, I don't. And I kind of wrote them all out kind of as a point here. We're talking about money. So with money, we only go to 2 decimal places to get to the cents. So to answer the question, after 40 years, we would have $1,497.45. So you kind of have to think about the appropriate rounding for each question. All right, so that would be compound growth. Compound decay is coming up. An adult takes 400 milligrams of ibuprofen, so that'd be like Advil. Each hour, the amount of ibuprofen in the person's system decreases by about 28.5%. How much ibuprofen is left after 6 hours? So this is, since it's decreasing, this is compound decay. I'm going to put down the formula. It's A is equal to P, and it's going to be 1 minus the R to the T. Fill in what we know. The starting is 400. It's going to be 1 minus R, and my R, I'm going to do the same thing, 28.5 divided by 100. So you want to put that in the calculator. You should get 0.285. And if you're good, you don't even need to use a calculator for this. You can just move the decimal place 2 spots, but sometimes people mess that up when it's a single digit percent, but this is okay. So this is minus 0.285 to the T. And I'm going to simplify this. So it's just going to be 400. 1 minus 0.285 gives me 0.715, and that's to the T. And again, I could find, I like writing it this way first without the time in there, because I could fill in any number of hours in this case. But to solve this problem, I'm going to plug in the 6. It's 0.715 to the 6th. And take a second, plug this in. I'm going to do the same. And I'm just going to round it to 2 decimal places because it doesn't say what to round to in this case. So I'm just going to say it's 53.44. So my final answer, this is in milligrams of ibuprofen, it's going to be 53.44 milligrams. I don't know if you'd round to the nearest milligram. It's a pretty small unit, so you might want to, but it didn't say, so I'm just going to do that. All right, so we had 1 instance of compound growth, 1 instance of compound decay. It's time for you to do some problems on your own. So here's your 3 SIA questions. Copy them down, give them a shot. Good luck, and thanks for listening.